So I'm Paul Elkington, I'm an Associate Professor at the University of Southampton, and I lead the Tuberculosis Research Group. And tuberculosis is a disease which kills 1.5 million people, mainly in resource-poor countries, and is becoming more and more resistant to the antibiotics used to treat it. The research we do in Southampton is based on the concept that growing cells in standard two-dimensional culture is not good enough to really understand the host-pathogen interaction. And so we now have a three-dimensional cell culture system, which happens in the TB lab behind me here. What we do is we infect cells with tuberculosis and then mix it with collagen and alginate, and we put it through a machine called a bioelectrosprayer, which essentially creates thousands of tiny droplets about 0.5 millimeter in diameter. And we've shown that the host-pathogen interaction is very different in the 3D cell culture, and we believe it reflects human disease much more closely than in the two-dimensional culture. So, for example, pyrazinamide, which is one of the most important antibiotics for treating human disease, works very well at killing TB in our 3D culture, but it doesn't kill tuberculosis in 2D culture. So the direction of travel we're taking this work in is to use the system, first of all, to screen for new antibiotics, but also to dissect host immunity. And we'd be interested in setting up this cell culture system in African centres so that we could then use it as an ex vivo measure of immunity and study why some people develop TB whereas others control infection.